Hello and welcome to another episode of the Fully Charged Show podcast, where today we're catching up with Claire Rowland from the Energy Systems Catapult, where she looks after the Whole Energy Systems Accelerator, affectionately known as WESA, and the Living Lab. If you have no idea what either of those things are, fear not, I didn't have a clue either. But what I can tell you is that they are truly phenomenal projects and organisations who are really ensuring that we can get to net zero homes for everyone in a timely fashion, but also in a much more fair, equitable and accessible fashion too. She is truly the authority on all things to do with user experience, Internet of Things, and designing all of this stuff so that it actually does what it's meant to do in a really, really neat fashion. So buckle up. It is honestly a truly fascinating discussion. But before we meet Claire, I have to tell you two things very, very quickly. First of all, my name is Imogen. I'm one of the presenters and producers here on the Fully Charged Show and Everything Electric Show. If you're not familiar with our episodes on our YouTube channel, I highly recommend that you go and have a look, go and subscribe, because we cover loads of the topics in a little bit more detail that we sort of skim the surface of in this podcast discussion. And second of all, I have to tell you about our live shows. Next up, we're in Farnborough in October, where there'll be thousands of electric vehicle test drives, loads of clean energy technologies on display, loads of interesting panel discussions. But I think the thing that is always the favourite thing for us is that there's just an incredible atmosphere of people who are complete experts and also people who are just, starting to dip their toe in all of this green stuff and clean energy transition stuff. And it really makes for just such a fantastic weekend. So do make sure to come along. All the details are in the description box below. But enough of that. Let's meet Claire. Claire, honestly, it is such a delight to be speaking with you. I mentioned to a few people within the sort of EV and energy ecosystem that we were going to be recording a podcast. And there were two sort of absolutely universal responses. The first was, obviously, we know Claire Rowland. And the second was, yeah, Claire's like the Don of all things Internet of Things, user experience. So no, you must be incredibly embarrassed for me to be starting this podcast by telling you that. But it definitely made me think, gosh, I need to do a little bit more prep than I would do normally. So anyway.
Well, that's a nice boost. That's a nice boost, and and thanks so much for inviting me. It's great to be here.
Oh no, it's an absolute pleasure to have you on, especially when I know what we're about to speak about. So, this is extremely exciting, and I want to make sure that we get into all the various different components of this conversation in the adequate level of detail. So, okay, let's start by saying, could you just briefly introduce yourself and give us a whistle-stop tour of your particular area of expertise?
Of course, yeah. So I started out in user experience and design innovation kind of longer ago than I maybe care to admit. First of all, working the web and then mobile, very early in mobile and sort of just general digital services. Around about 2010, I started specialising in Internet of Things technology, so services built around bits of connected hardware, and worked on all kinds of things in that sort of field, from breast pumps, skincare devices, industrial power tools, but also lots and lots of energy products and services. So some of my friends call me thermostat woman still because I've worked on so many heating controllers, but also things like solar PV monitoring, several smart meter rollouts, just kind of various kinds of energy kit around the home. In recent years, I've moved more into product management, and I now work for Energy Systems Catapult, which is a not-for-profit clean energy innovation agency. And there I run the Living Lab and the Whole Energy Systems Accelerator trial facility.
Oh my gosh. So Living Lab and Whole Energy Systems Accelerator is something that we definitely need to get into in more detail. But I suppose, because we talk about on the show user experience all the time, but I think it probably is worth it at this point having just so we're all on the same page, what exactly is user experience?
User experience basically is about designing things that work for the people who are supposed to be using them, and so that's things like making sure that the product or service that you're designing actually meets the real needs that they have. So is it does it do the right things for them? Is it easy to use? It might not be easy. It might be designed to do something that's quite complicated. So it's not necessarily about making everything super, super simple all the time, but making sure that it's as simple as it needs to be so that the people who need to use it can use it. And then it's also about making things that people want. And that might be superficial things or things that seem superficial, does it actually look nice? Is this something that people might want to have in their homes? Just is it pleasant to use? Does it talk to them in the right kind of tone of voice? Does it feel nice to use?
And it's an interesting thing because it's one of those things that you notice it when it's absent, like when
Mm.
something is actually not very desirable, really clunky to use, and an absolute pain. That's when you're like, user experience clearly hasn't been considered in sort of a whole ecosystem approach. And actually, it gets you thinking, well, user experience should be like an absolute basic requirement in any product or service, but it often isn't. And I'm sure we'll get into some of the reasons why as we go through this conversation. But I want to ask you about the Living Lab, not to be confused, I think, with one of those kind of green living walls that you see in conference centres,
No,
but actually something far more important and exciting than that. But what exactly is it, and what is it trying to do?
I might as well start from the top. So Living Lab is a facility for trialing new energy innovations aimed at consumers with real people in real homes. So that might be things like products or services, energy services, or even policies. So very often some of these things might be, the process for this might involve testing perhaps a piece of hardware in a test lab, or it might involve building a software model to see kind of how many people you think might use this, and what might that look like. Um, but when you put things in real homes with real people, real life gets in the way. So do things work in homes of different types? Do they work for people who've got kind of, lots of family live on their own, or have got lots of family coming and going? Do they work for alongside some of the other technologies people have in their homes? All of these kinds of questions. Do they work just for people who are really busy and don't want to be having to think too hard about how they use it? Do they work for people who really can't be without heating, for instance? So real life is a lot more complicated than laboratories. And so that's where we come in as a way to provide that kind of testing that helps make sure that there's nothing horrible is going to happen when you launch this thing before the market. The other thing that we do, so we've got 3,800 homes signed up now, and a lot
Wow.
of them are sharing data with us of some kind. So the other thing that we do, we've now got quite a good repository of data that helps us understand how real people use energy. And so also we are starting to provide that data to some of the people that work with us to help them understand, how energy consumption is changing as more people kind of electrify things. And so it's a good way to kind of identify new opportunities for innovation.
God, 3,800 to sort of create a distributed Living Lab. The name is definitely appropriate. And it's so fascinating because we went to Energy House 2.0, attached to Salford University at the end of last year. And for those who maybe haven't seen that episode, and we'll link to it in the notes, it's a test facility where they've got these new homes within a very, very controlled test facility to test things from minus 20 degrees up to plus 40 or whatever else. But it's such a controlled environment to kind of come out with a specific figure of how this specifically works in a particular efficiency. And the reality is that the variation in our homes and ways that we live, family dynamics, attitudes, that introduces so many more variables. And from my perspective, I'm like, oh my goodness, how do you even begin to dissect that data and draw any kind of meaningful insights from it? It must be tricky.
Yeah, so what we typically look at would be a mix of data that we capture from sensors in homes. So let's say we are testing a new piece of equipment. There are other kinds of trials that we do as well, but that's that if we're talking about that sort of example. So we might be monitoring households' overall energy consumption. We're monitoring how that piece of kit is being used. We might have other sensors in the home. So if it's a heating product, for instance, we do quite lots of heating related work. We would have temperature monitoring, humidity monitoring. We might have we might have a heat meter that's monitoring the efficiency of the heating system, so we know what it's doing, but also how efficiently it's running. We might we might look at the heat loss in the building. But then there's also, so that's your kind of your sensor data, that's your hard science. But then there's all the kind of the people stuff as well. So what is it like to be living in a home that's got that system? How easy is it to use? Are people happy with the ways that it's heating the way that it's heating their home? It might be different from what they've experienced beforehand. And so all of those things are also really, really important. And we look at that across lots of different types of homes, kind of with different sort of types of household living in them. And so you're right, it is really, really complicated. But I think it's that bringing together of the hard data, kind of the big sort of big data, if you like, and what we might, and the kind of the sort of the thick data, as some of our researchers might call it, which is that kind of like rich insight into what it's actually like for the people who are living in those homes.
And in those 3,800 homes that you currently have within the Living Lab, how closely do they represent sort of the distribution of different types of households and demographics that actually exist in the UK?
So we have a huge variety of people in the lab. We've got homes all over the UK. We've got homes of all kinds of different types, big detached houses, flats, everything in between. We've got a huge range of people. So we've got people who've got, people who are quite well off, and we've got people who are on prepayment meters, who tell us that they're struggling to pay their bills. So it's very, very broad. We are not exactly trying to mirror the UK population. And that's the reason is that the demand for our sort of trials and data tends to fall into, there's sort of a couple of camps, if you like. We've got, we slightly over index on people who've got low carbon technology. So things like EVs and chargers, heat pumps, solar PV and battery in the homes. And that's useful to us because it means that we can help, we get data on that shows how energy consumption is changing as more people take those things up. So some of the work that we do is looking at what future energy demand is going to look like. So it's really helpful to us to have those people, and also those are things that we can monitor, that we can and even control in some cases as well. We've got lots of people who might have one or two of those things, or don't have any of those things. So you might live in a kind of average house with a gas boiler, let's say, but maybe we're monitoring their heating or something like that. And then we also we keep a close eye on the number of people who are potentially what we would call low income and vulnerable. So the Catapult has quite a strong what we call Fair Futures facility. So we do this is outside of the Living Lab, but we look at, one of our kind of key themes is making sure that the energy is, everyone has to use energy. Is it fair for everybody? So we do keep an eye on. Those are people that we're very keen to involve in trials. So we aim for a mix because energy has to work for everybody, and we want to be able to involve always involve the right people in trials. But we do have a few more kind of on the sort of early adopterish side, because that data is important to us.
Which also links to the work with PNDC, which I will come on to in a moment. But before I do, if anyone listening or watching this podcast wants to submit their home to the Living Lab, do they have the opportunity to do that?
Absolutely. It's open to everybody, everyone in the UK who's over 18. So all you have to do is go to a website. The address is livinglab.energy, and there you can find out a bit more about it. And if you decide that that's something you want to sign up to, then you can. It's a pretty straightforward process from there. So the website links you through it. All we'll ask you to do is create an account and then fill out 20 questions about your household, about your home. And then if you have a smart meter, or you have an EV and charger, you have certain kinds of heating controller that we support, then there's the opportunity to link those to the lab and share your data if that's something you'd like to do.
I would hazard a guess that we actually have quite a lot of listeners who probably are already in the Living Lab, and quite a few more who'll be like, oh, I'm going to go to Google and this sounds really cool. Okay, I'm going to consult my notes here because I want to make sure that I get this correct. So you mentioned at the start of this around the Whole Energy Systems Accelerator. Do you call it WESA internally?
We call it WESA.
WESA. I really had visions. It'd be like, WESA, like, anyway, that's how I've been saying it every time I've read it on my notes.
Sorry, I'm thinking we're beginning to think that perhaps it needs a slightly snappier name, but it's WESA for now.
And it looks good, and it's what it says it is. Whole Energy Systems Accelerator, but that combines the Living Lab with PNDC, which I then went and had a look at PNDC, and it is truly phenomenal. It's an energy systems test and demonstration facility in conjunction with the University of Strathclyde, and they actually can emulate an electricity network complete with substation and all sorts of high voltage bits and pieces. Really incredible. And I should say, when we talk about whole energy systems, we're talking heat, power and transport. But what is the purpose of Living Lab and PNDC and Whole Energy Systems Accelerator coming together? What is that trying to achieve?
So the Living Lab on its own is a way for us to test product, services, policies that with consumers. What WESA gives us is the capability to be able to look at, when we say whole system, we mean, well, there are consumers and homes, there's also the energy networks, and then there's the energy markets as well. So, and that includes everything from the kinds of regulations that govern, how the energy system operates, to the ways that energy is sold on wholesale markets, to the kind of retail offers that your energy suppliers, what are they, what kind of contracts are they offering their customers? So there's all kinds of stuff that's the sort of market piece. And what we've done with WESA is basically build something we call a feedback loop that combines all of those. So I like to explain it as kind of a time machine. So when we test things in homes, we're testing them in today's under today's sort of market conditions. But sometimes what we want to know is whether something, a new innovation will work kind of not just now, but also into the future. So what if some of those regulations change, or the market, the way that markets operate changes? We're talking about all kinds of changes to coming in that sort of world to support net zero. And also, the networks don't remain kind of the same. All of the energy networks are upgrading the networks, and the conditions on those networks are going to change. As more things become electrified, we have more renewable generation. The kind of the way that the challenge for the energy networks basically to manage, which is managing supply and demand, is going to look really, really different into the future. So what WESA allows us to do is to build a kind of simulation, PNDC, to build a simulation of like a future piece of the network. Let's say perhaps it's 2035 in Dundee, and certain it's been upgraded in certain ways, but and there's loads more wind and loads more. The new government wants us to get to 100% renewables by 2030. So that picture starts to look quite different. Some of the regulations and the markets might look quite different. And so what we can build with that is effectively a time machine for our trials. So we can say, what if, what is a new product? Does a new product kind of work in that future? What is it like for consumers to live in that future? So we can sort of simulate some of this kind of future stuff. Look, you don't even have to be living in Dundee. We can take a bunch of homes all over the country and kind of pretend that they're in Dundee. So it's a way of testing whether those new things, whether it's on the consumer side, like the new products and services, or even kind of some new piece of network technology, what impact might that have on homes, or a new regulation that might change the way that energy is priced kind of on the markets. What impact do those things have on homes? And it's kind of how does that change energy demand? What does that do? So the whole thing kind of like feeds together and creates this kind of future world. So we're kicking off a couple of trials. We've started running trials with us already, but we're kicking off a couple of trials this winter. We're actually going to be controlling EVs and potentially heating in people's homes, kind of under some of these kind of future scenarios.
That is unbelievably cool. And it was one of those things when I looked at, everything that's going on at PNDC, what kind of sits under WESA, and I was like, this sits so firmly in the fully charged everything electric show sweet spot. I cannot believe we have not spoken about these things before. And the opportunity that you've got these real homes in the real world, distributed amongst the country, but you can almost, you could have that as a distributed system, or you could kind of make it so it looks like they are all in the same area from a data perspective. And then to run these scenarios through PNDC and to have these these sort of virtual hypothetical future scenarios being tested also in the real world using real world data today, like the whole thing is truly extraordinary. And so I suppose I want to ask you sort of some of the more nuanced questions around some of the specific things that you're looking at. But I imagine when you go for dinner with your friends, they're like, oh, so you're looking at, what happens when everyone has an EV, and can the grid cope? But I suspect that you probably have quite a specific point of view on that particular question.
Oh, my friends don't all ask me those questions, actually. But yeah, I think we're already seeing interest in the smart meter data that we get from the Living Lab, and we've got probably, and this is across all of our homes, not just the EV homes, but I think we've probably got about 30-40% of the people who are sharing smart meter data with us have an EV. The kind of demand, the sort of standard demand. Your listeners might be familiar with the standard demand curve. There's a electricity demand typically looks like over the day for the country. There's a peak small peak in the morning when everyone gets up and starts cooking breakfast. There's a much bigger peak in the evening where people are using heating and hot water maybe, and and cooking and stuff. Our peak for our smart meter homes in the Living Lab is in the middle of the night. and it starts at there's a little one, and then there's a bigger one, and another bump, and it corresponds with two of the major kind of more modern energy retailers EV tariff cheap rate kicking in, basically. So that overnight demand is massive. And so that shows, that we think, oh, we're doing the right thing, charging in the middle of the night. Energy is cheaper. That's it. But we see the problem. The problem is is going to get much more complicated to manage. So I think this for me is a really interesting challenge. That obviously we are trying to get more people to electrify their cars, electrify their heating. That's the really big. That's a really important thing to do. Because that's so much of our carbon emissions. But that does create these challenges in terms of not just generating electricity. That in some ways we've shown we're quite good at generating clean energy, but how do you get it to the people who need it at the time at which they need it? Which is a huge challenge in terms of being able to you can if it's not windy, if it's not windy, but we all need to charge our cars and fire up our heat pumps, and there's not enough solar at the moment. We fall back on other ways of generating electricity which are not green. And I think it's a lot of people, a lot of consumers probably don't realise that just because they're paying, they might be paying their energy supplier on a green tariff, the promise of 100% green electricity. But if there's no wind and there's no solar, and it's 6 o'clock in the evening and everyone's trying to cook the dinner, those electrons that you're getting might have come from a gas fired, might well have come from a gas fired power station. And also a lot of the renewable energy generation is in Scotland. If you look at National Grid, do a really quite a nice app that shows the sort of relative carbon intensity across different bits of the UK. And the north of Scotland is nearly always deep green because they've got lots of wind and lots of energy. There's lots of clean energy. Up there, they have the challenge of actually managing to use it when it's coming in. Down in the south of England, you might see that actually bits of the country are on much higher carbon energy mix, electricity generation mix at that time, because that energy is being generated up off Scotland doesn't necessarily mean that we can get it down. We can get it down to the people in the south. So there's all sorts of really interesting challenges. Yes, we should be electrifying things, but we also need to plan for ways that we can make the most efficient use of that energy where it is and get it around the country.
Yeah, because I think that is something that not everyone has that full visibility of, is that when you have a green tariff, for example, that doesn't always mean, as you say, that you're going to get green electrons into your home, but that energy supplier has bought an amount of green electricity. So you have ensured that amount of green electricity is going to be used and bought, but the one that could arrive into your home doesn't necessarily mean that it's come from wind or solar. But it's fascinating because I suppose that you could extrapolate that scenario. And actually, that could give a really detailed map of, well, this is what our stationary storage strategy needs to look like. And this is how we need to incentivize peaks to be shifted to different bits of the day. But ultimately, with the aspiration that consumers don't have to think about it at all and don't have to engage with it at all, because it should just happen.
No, I definitely agree with that. I think it's been really interesting seeing things like the National Grid Demand Flexibility Service. People have been incentivized to shift demand away from peak times, and lots of people have taken part, and that's great. But I think ultimately the best solutions for people are the ones that don't require that, allow them to go about their day, do the things they need to do, not have to think about it. Anything that requires people to think or go to a lot of effort outside of their kind of usual daily activities is not going to give us the scale of change that we actually need. So I think those things are nice and they're interesting. They're not ultimately the big solution. And I'm a people in homes kind of expert on the people in homes bit, not on the network challenges per se. But yes, there are things we need to do kind of system wise in terms of incentives and in terms of storage on the grid. But also we are, as consumers, going to have to get more engaged with energy, not to the point where we're saying, oh, well, I'm not going to cook my kids' dinner at 5 o'clock, I'm going to cook it at 11 o'clock at night, because obviously that's not practical. But I think we are going to have a little bit more understanding that electricity doesn't just come out of the socket when you need it. I think we've thought of it a bit like water, that historically we've thought of it a bit like water, and in the UK we've for a long time now most of us have had pretty reliable experiences that electricity is just there when you need it. But I think we are going to have to become a little bit more aware that there are some challenges involved in making the best use of renewables, and some of the technologies in our homes are going to, might need to sort of shift around a bit. We might need to have some different technologies, and I think things like EV smart charging, vehicle to grids emerging. Those are great examples of that. But we also need to look at how we can provide. We talk about flexibility. How our heating systems might be able to provide a bit more flexibility as well.
I definitely want to return to this because there are so many aspects that I think there are just clear parallels with your world and Internet of Things. So I'm parking this for a moment, and I want to make sure I don't forget. But before we come to that, I wonder if you could just share a couple of the sort of specific things that you've been looking at under the umbrella of WESA and the Living Lab, and just kind of if you could share some of your insights on any of
Yes,
those.
of course. I think so. So there's a huge trial that we're just kicking off at the moment of 1,000 homes. So I don't have the insights on this one yet, but it's so big, it's definitely worth a mention. This is a project for the Department for Energy Security and Net Zero, so we call DESNOs internally, and it's looking at helping government understand how to better support people in what we call hard to decarbonise homes. So typically these are people who've got solid walls, so there's no cavity wall insulation, gas heated, typically older homes. It's a bit more difficult. It's not always quite so easy to work out how to insulate them and how to get them onto low carbon heating. So that's a big. We've got 1,000 homes with various sensors going into them that we're going to be monitoring to understand how they use heating. Some of those homes are going to receive what we describe as intervention. So that might be some insulation. It might be, in some cases, it's a new technology. We're going to be looking at how that changes, and what impact that has on their energy consumption, but also on how the heating is working in their homes, so that we can derive some advice, essentially advise the government on policies they can take the insights from that, and that will be used to drive policy around decarbonising home heating. So that's one thing. There's another one, a couple of the WESA trials. So there's one that we ran fairly recently, which was looking at helping energy networks understand what energy demand from heat pumps looks like in a really, really cold winter. So when the gas networks plan for kind of the capacity that they need, they use a scenario of a 1 in 20 winter. So 1 in every 20 years you would expect to be as cold as this. That's the kind of the extreme. So as we move more towards electrified heating, we start planning. The electricity networks need to start kind of thinking about those kind of scenarios as well. So we had a load of homes with heat pumps, and we monitored their electricity demand, and then we kind of modeled that, did some clever analysis on that, to make it wasn't a 1 in 20 winter at the time, but if this had been a 1 in 20 winter, what would have happened to that demand? And so, and that was, so we provided that back to, and what did that actually do on the network? So there was some clever PNDC network model involved in that as well. So we were able to say, here, this is what this looks like, and this number of heat pumps on the network, this is what this looks like, and that was fed into helping them plan so that the networks are able to support that. We've got, and then finally, we've got another WESA trial that's running this winter, and that's testing a space heating battery. So this is a battery that stores not electricity, but heat. I'm not a chemist, but I understand that the chemical it uses to do that is very similar to salt and vinegar crisp flavouring. And the way that works, it allows when there's lots of cheap green energy, the heat pump will run and generate heat, which is stored in that salt and vinegar crisp flavouring. And then during times of low wind, not much sun, that heat can be used to heat the hot water for the heating system. So the idea is that this means that people don't get cold, but you don't have to run the heat pump so much at times when there's no green power, basically. And the WESA angle on that is looking at kind of some future scenarios, and how does this work? How well does this work? How does that help the networks, not just now, but also into the future?
My God, this is unbelievably cool. And I suppose, and I said to you earlier, like, I imagine your friends ask you about such and such, and I think it really shows that I hang around with maybe too many energy and transport people for whom that absolutely is our pub conversation. But I think the pub conversation, certainly that I've experienced, is, if we all have heat pumps, that's going to be a disaster in winter. And actually, you're part of the team that are really putting that through its paces and saying, is it a disaster? And actually, how can we mitigate that? Which is extremely, extremely cool. But I think, and I hope that this kind of can segue nice into this next section, because I said I'd come back to this idea of, how do we change our mindsets around energy and sort of the user experience of energy? And you said how, I think to date, we've really experienced energy in a similar way to water. You turn on a switch, it just happens. And, the language that you read about it is that we've been consumers of energy and we're about to become prosumers of energy, in as much as not only are we consuming it, but we can generate it, we can store it, we can move it around we can have a much more tangible relationship with it. But that makes it hugely more complicated with regards to then balancing it within our homes. So, for example, understanding that, it's a sunny day. Okay, let's store loads. Oh, what does that mean for the dishwasher? What does that mean for the washing machine? What does that mean for the car? And that's where it seems that there's the potential for a tremendous amount of parallel with the world of Internet of Things, that actually we need to get to this scenario in which that just happens. We're not thinking about it. And presently it feels like we have a lot of early adopters who are, already thinking about things like V2G and storing energy, but they're quite happy to be super involved in understanding how that moves around. And as we get to the early mainstream, that's when you get into territory people who honestly just don't want to care about it. And that is, I think, obviously utopia. That's how it should be. So I wonder if you can share some of your views on where the parallels do exist with the Internet of Things, and some of the things that we should be learning as we transition into this much more tangible relationship with energy and electricity.
Yeah, I think the parallels of the Internet of Things are in having lots of devices that all have some degree of decision making for themselves in many cases, that in the home that then need to coordinate. And this was always a really, really difficult challenge that I think sort of wasn't entirely solved in IoT world, as I call it. So if you've got solar and you've got a battery and you've got a car and you've got other devices in the home, an EV, and you've got other devices in the home, what do you decide to do? And you've got excess solar at that point. Where do you decide to put it? Does it go in the hot water tank? Does it go in the car? Does it go in the battery? Where does it? What's the best thing to do at that point? And there's quite a lot of, your heat pump will be doing its best to try and be a clever heat pump, and your hot water tank will be doing its best to try and be a hot water tank, and the car's trying to make sure that it's got the charge that you said you wanted for the next time you need to use it. So all of those things are kind of trying to make decisions on their own. And then there's probably, and this is the bit that's only just sort of beginning to emerge, some sort of central brain in that system that understands what you want. And that might be aligned with the battery. It might be aligned with it. There's the various different sort of companies essentially kind of going on. We're going to make a battery centric energy management system, and other people saying we're going to make a heat pump centric energy management system. So for consumer, first of all, there's the challenge of understanding what all of these things are doing and trying to get them to work together. And we don't have the standards that to get those things to work together, particularly from different manufacturers, are only really sort of starting to kind of emerge now. But then there's just the logic of it all. How do you as a consumer tell the system what you want? And I used to get this a kind of a simple example from IoT days, that you could easily get a scenario where there's a light in your home that's flashing on and off and you don't know why. And it might be because it's getting an instruction from an app that's trying to save energy, that's like, turn off the light when no one is, when no one's in the room. And it might be getting another instruction from like a kind of security app that's saying, like, turn the light on and make it look like there's somebody at home. So you get these kinds of conflicts. And so, one part of the system's trying to do something and the other part's trying to do something else. And you don't have to have very many of those parts before it very quickly becomes very, very difficult as a consumer to deal with that. And I think the answer is probably that we never quite solved that for the Internet of Things, and we don't, as we thought. 15 years ago, we thought we'd all be living in these homes that had loads and loads of connected stuff. And the reality actually is that most of us have some of it, or many of us have some of it, but it's not this kind of home automation utopia where you walk into the house and everything's like magically happens. So I think the answer for energy is probably that many of us will outsource that decision making to somebody who runs a service for us, somebody who will offer us, maybe it's an energy supplier, it might be someone that sold us the technology, who knows? I think there's maybe probably some more kind of more kinds of players, if you like, here that might
Mm.
emerge in that space, and will say, "Do this for me. Just give me this is what I need. My car make sure my car's got the charge I need. Make sure my heating is keeping me warm at the times I want to
Mm.
be warm. Make sure I've got hot water at the right times, and that decision making will happen kind of
Mm.
behind the scenes."
It's fascinating because there are definitely, various platforms that are emerging that are doing that kind of systems integration to kind of balance that and give these really, really beautiful interfaces so you can understand what's going on. But there are also just a huge number of stakeholders involved in this who could want various different bits of the pie. For example, actually, your bank, in terms of
Yeah.
if they start to think of energy as a unit and sort of Internet of Energy era, there's the car companies from a V2G perspective, there's utilities, there's sort of software companies, there's so many different people who could get a chunk of this pie. And it, as you say, it quickly becomes super duper complicated, not only from those interactions, but also from who is doing what. And as you were talking, the sort of vision that I had in my head is like the scene in Cinderella where they've got all the sort of woodland creatures helping to tidy up. Like there's just a lot of things going on. I also should say at this point that you wrote the book, I think safe to say, on designing connected products and user experience for connected things. That's the official title. But that really, is regarded as the sort of the go-to place of understanding that kind of those kind of interactions. Okay, so we've kind of spoken about there's the technological challenge of how these things need to integrate together. There's also the technological challenges of developing some of these technologies in the first place. But there's also another component of it, which is the deeply human component of how these
Mm.
things become compelling to use, easy to use, actually fit within people's lives, ultimately become invisible and just kind of work. You have this incredible overview of all of those different aspects. So, from your perspective, what do you see as the greatest hurdle at this juncture to realizing net zero homes or carbon free homes?
So I think there's a few things. You asked for one. There are a few things here. I think there are lots and lots of barriers. The first one is money for a lot, for many people. So just having access to the funding or the finance, the grants to support people to switch to cleaner technologies. That's an enormous barrier. Then it's the kind of, I guess, the sort of customer journey type thing. So you're talking about the different uh, talking essentially about a world where people might have to choose between not just energy suppliers, but also people who are going to manage the kit in your home. That's orders of magnitude more complicated. And I think even at the moment, just getting good advice on what to do to your home first, and people to do the work in some parts of the
Mm.
country. It's there's just not enough people who are trained to do the work. That's really confusing. I'm trying to retrofit an old house. I work in the industry, and I'm getting lots of conflicting advice that's making my head spin, and finding it difficult to get people to do that work. So, if it's hard for me, it's going to be really hard for
Mm.
lots of people. So there's lots of issues there, but part of it is about having the people to do the work, and part of it is about just kind of making it easy to know what to do, having people that can sort of help you through that process. And then there's the technology issues. The kit's not always very, very user friendly. So, the products and services can be quite technical. I spent a lot of my career in the tech industry, which has not universally, but has generally got better at making a consumer experience over the years. But I think there's still quite a bit of the energy industry that's very, very, it's very tech driven. That's fine. We need lots of
Mm.
innovation in that space. But I think there's sometimes nobody wants to make things that are difficult to use. Everyone wants to do the right thing, but I think sometimes there's not the kind of quite the same depth of understanding as there is in parts of the technology industry as to what it takes to do that really well, to really understand really understand user needs and really do
Mm.
good design. So that is I think those are some of the big challenges. But I think one of the big things for me, if I could pick one thing to happen tomorrow, it would probably be to change the differential between gas and electricity prices. So gas is so much cheaper than electricity in our homes for various reasons. One of those is that the cost of generating electricity pricing is linked to gas generation. But we know that renewable energy is so much cheaper to generate than gas. So there's a few other things there as well. But I think if we could, if I could move the lever on one thing, I think if we could make it an absolute no-brainer that switching to electric heating would be cheaper, would save people money, over being on gas, and make that so obvious that it would probably drive quite a lot of progress in some of those other areas as well.
I mean, we've definitely heard that before in various sort of podcast episodes and various discussions, because ultimately, like, of course, people want to make the right decision for the future of their home, the future of their sort of comfort within their home, the future of their children, etc., etc. All of those incredibly important and noble things. But ultimately, people want to see a benefit in their pocket, and they want an experience that is cheaper. And it's that sort
Yeah,
of, well, what's in it for me? And until we get to that point, it's always going to be a slightly uphill battle. As soon as we
yeah.
can kind of cross over into that transition, then it becomes like a total no-brainer for everyone. So yeah, I definitely agree with you on that one. So I suppose, and you've kind of touched on this a little bit already, but if you did have a kind of a playbook for people developing these clean energy technologies, let's say it's a charger or a smart meter or whatever, what would be your top tips and advice?
So in terms of
Yeah.
consumer experience, I think really understanding the market. I mean, this is just how to do user experience, right? I'm not saying anything particularly revolutionary here, but I think really understanding the people for whom you're designing. I think
Mm.
EV charging probably we understand quite well now, so that's not such a, there's a lot of that's a bit more mature. That some of the things we work with, we kind of really novel heating systems. It's there's more work to do there. If you're designing something that's completely new, there's a lot more work to do to understand who might be the people who use it and what do they really
Mm.
want from it. um, and investing in good design. Make things look like people want them, but also invest that time in prototyping things really early on. You can prototype sort of the way that somebody might interact with a piece of kit,
Mm.
on paper, or you can kind of make models of it that don't have to work. And just doing that kind of testing and doing that sort of testing and iteration um, right from the start, making sure that involving users. Basically, the more you can involve them until you're not learning anything anymore, and then you've learned everything you need to learn.
Mm.
So it does. It's going to seem like it takes longer. In some respects, it will save time,
Mm.
and it's definitely, because you can eliminate the wrong decisions early. That's the thinking, and also, by the time you actually take that to market, you'll know that you've got something
Mm.
that people are going to want and they're actually going to use. So it's, the cost of doing the wrong thing is higher.
Yeah, and additionally, I guess you don't end up with these sort of Frankenstein devices which have had to do these retrofits when they've understood, this was not quite logical, and now we need to do this obscure thing which totally doesn't make sense.
Yeah.
Um,
It's easy. I'm sorry, I was going to say it's easy. It's easy with services. It's easy kind of with software. Like if you make something that's a bit wrong and you kind of get it out in the market, and then you
mm,
can go, oh, that wasn't quite right, and you can change it. Um, it's really hard if you're making something that involves hardware. We say hardware is harder. You can't change your mind, so you
yeah.
have to make sure early on that you're making the right thing that works in the right way. And there are lots of other pressures, of course. It's like
Mm,
the ideal user interface might be something that's quite expensive to produce, and that would make the device so expensive that no one would buy it. So,
mm,
I'm not a design purist about these things, but I think it's about understanding what the most important priorities
mm.
are for the user.
I also wanted to ask you about a project which I know perhaps didn't have the most successful outcome necessarily, but was a really interesting exercise, and I think a hypothetical scenario perhaps. And it was all around looking at how you offer temperature as a service rather than number of kilowatt hours as a
Mm.
service. Talk to us about that.
So that was a project called Heat as a Service, which ran at the Capital. This is actually the origins of the Living Lab back in sort of about 2016. I did work on some of that in the early stages as a contractor to the Catapult. So but it's before my time as a permanent employee. Um, the idea there was that, so instead of selling people kilowatt hours for their heat energy, which most people don't really understand,
Mm.
you could sell them an outcome. So if I want my home to be 21 degrees between these hours and 18 degrees at these other times. But I don't really care how you do that. You then create opportunities for people who are providing that service to say, actually, we think we can deliver your heating more cheaply if we put a different technology in. So it might be a way to get people onto heat pumps. So instead of paying instead of, it might involve you actually leasing your heating system kind of as part of that deal. So the idea was that you could, people would essentially pay for an outcome, and so you could say, well, if I heat my home to these kinds of temperatures, then that might cost me this much. And so you'd have a really clear relationship between what you wanted and how much it was going to cost you. And in order to get to that point, we had, I think, 30 homes at the time, which all had these custom systems, custom heating control systems that have been fitted, loads and loads of sensors, kind of building physics, understanding, like different types of homes, how do they heat up, how do they cool down, what are the factors there, and devices on the walls in people's homes so they could say, oh, I'm a bit cold. And so they could sort of notch it up a bit, and we go, okay, this will cost this much. So it was a way of it was a way of seeing whether you could deliver heat to people in a different way. And although that was a few years ago, and there was a scheme with Bristol Energy that sort of actually did this. They actually did this kind of in the market, or something like it. But we're still working on that. We're still kind of working on that idea now, and it's starting to come back as ways of saying, what if it's really expensive to get a heat pump, for instance. That's an expensive upfront cost. That's too much. That's too much for people. But what if you reframed that as paying a monthly cost for somebody to for use of a heat pump plus the servicing plus the energy that's being used to deliver. So it looks like a kind of just a sort of flat monthly cost to you. Behind the scenes, the supplier of that service has got some options, so they can figure out what they think the most efficient and cheapest thing for them to deliver is, and it makes life much simpler. The idea is it makes life much simpler for the consumer. So consumers that we tested it with did actually like that idea. It was quite challenging at the time. It's quite challenging in practice to deliver, because you've got to understand so much about the building in order to be able to kind of tweak the system. But the idea is coming back.
That is so interesting. And I think this is where the fully charged everything electric multiverse comes together, because are you working with Heatio on that one?
We are, yes. I'm not closely involved with that project, so
yeah, because we have interviewed Heatio before, and again we'll link to that episode in the notes on this one. But again, looking at that kind of energy as a service sort of ecosystem, and I think it's such an interesting trial, because temperature is something that people more viscerally understand. People know what 18 degrees versus 25 feels like, whereas kilowatt hours is totally more abstract. And, even people within the industry always sort of flip-flop between kilowatt hours and kilowatts and get confused between the two. Degree C, we understand what that means. But also provides an incredible amount of incentive to the manufacturers of these products to be more efficient to reach those temperatures at a reasonable cost. Plus, a consumer doesn't feel like they're having to compromise on what comfort feels like to them. So super interesting. Really, really keen to keep tracking the outcome of that.
And I think we will see more shifts towards these kind of energy as a service models. So it's like, it might be like, and we see some of this at the moment, right? It's kind of with your EV, perhaps you get your out of home charging bundled with your energy bill. Maybe you can have your car lease and your insurance kind of bundled with those things. One of the things that we are looking at, and there are some of the energy suppliers in the market now are kind of experimenting with sort of faking these kinds of tariffs, is what if you charged people differently for the kilowatt hours that go in the car than the kilowatt hours that they use to cook the kids' dinner? So there's a lot of we want people to flex demand, and try and avoid the peaks, as it were. But some of those, that's much easier to do with certain things like car charging than it is with other things like cooking dinner. So what if we priced energy in ways that, what if you paid effectively a different tariff for your EV, and maybe the cost would be cheaper if you agreed that your energy supplier or somebody else could take control of your EV charging sometimes. and this is sort of exists at the moment, but it's not actually legal for it to be done in quite that way. So maybe you could say, well, actually, the maximum price you might pay for EV charging might be really expensive, but like the low price is very, very low. But your kind of general household consumption, for everything else you do, might be much, much more stable. And maybe that might feel like a fairer way to people to kind of incentivize some of that shifting. So these are things that we're looking at testing actually this winter.
And I think that's such an important point, because actually that ability to be flexible about your energy consumption assumes a couple of things. One, that you're probably pretty affluent and you understand the market a little bit, and you have that, spending power to be able to shift and to have that choice. You may even have a battery, so actually you don't even notice when those shifts are, because you're just charging a battery when it's cheap to do so and using it at the times when it's expensive to draw from the grid. But there are many instances where people don't necessarily have access to that flexibility. It is not compatible with a baby's bath time, for example, to bath a child at 2 a.m. when electricity is really cheap. Likewise, when you cook dinner. And I picked up on that on a talk that you gave fairly recently, and was like, that's a really interesting point. How are those sort of very, very specific and very, very human use cases being considered fairly, and then being packaged up into services that work for every kind of person? Yeah.
And I think it's, as part of this kind of reframing our relationship with energy as something that's more transactional, that's a bit more, I don't want people to be thinking about energy all day. Most people to be thinking about energy all day because, most people don't want to think about energy all day. But, I think as part of reframing that relationship, there's a lot of questions around what is fair, what is a fair way to price it. And there's probably going to have to be some notion of us not just as passive consumers, but also as providing something back to the grid, whether we're actually exporting energy to the grid or whether we're just agreeing to use less of it at certain times. And I think there's a value on that. There's a value on that kind of demand shifting, which we haven't quite figured out. And to me at least, it feels much fairer to kind of have very sharp incentives for shifting things that can be shifted, but not to penalise people for the things that that can't be shifted. So like cooking your kids dinner, or kind of bathing the baby. So I think we're doing some work this winter actually around kind of what we're calling a sort of looking at policy and regulation with a living lab trial to sort of start to explore some of those issues. And one of the things we want to look at is what feels fair to people. What feels fair, what doesn't feel fair. So I think it's a really, really interesting area.
Well, I've just noticed the time and spotted that we've been speaking for almost an hour, so we are going to have to end it there. But something that is so striking through this conversation is that we've got technology, we can trust that it sort of works, that we can see that things are becoming more energy efficient and carbon free. But it is so deeply reassuring that there are organisations like the Living Lab, or projects like the Living Lab and WESA, that are ensuring that this happens in a really fair and strategic way. And I have no doubt that we're going to be doing many Everything Electric episodes on some of the work and trials that you're doing in the very near future. So thank you so much for giving us a bit of a flavour of what's going on, and I'm looking forward to doing some even bigger deep dives. So thank you so much for joining us. That is all that we have time for today. But before you go, if I could ask one teeny tiny favour, if you could give this episode a like, a comment, a subscribe, or even a share with your friends, we would so appreciate it. It really does help to ensure that we can keep on sharing the cool and important stuff in this clean energy transition. But that's it. Thank you to Claire for joining us. Thank you to Katie from our team, who will be editing this episode. And thank you to you. So if you have been, thank you for listening.